Let's look at some examples of how special right triangles can help us find missing sides easily. In my first example, got a right triangle. It's not telling me if it is a special right triangle or not, but it sort of is because I see this length is x and this length is x. That means that this is an isosceles right triangle. So if I'm isosceles, those two base angles are congruent. So since the two acute angles add up to 90, they both have to be 45 degrees. So this actually is a 45, 45, 90 triangle. So if you have the hypotenuse, the way you get the shorter side is you have to divide by the square root of 2. So you take the hypotenuse and you divide it by the square root of 2, which that's easy. It's just 9. So each of these values, these x's, are 9. In our second example, we've got the same situation where they haven't told us if it's a 45, 45, 90 or a 30, 60, 90, but I can see that it is isosceles. Those are the same length. So once again, the only way I can have an isosceles right triangle is if the two base angles are 45 each. So in this case, I know the side and I want the hypotenuse. If you know the side in a 45, 45, 90, you just multiply by square root 2. So don't get confused here. This is the side, and I want to multiply it by the square root of 2, which is good, because the square root of 2 times the square root of 2, that's just 2. So the hypotenuse length is going to be 30. In my next example, I have a 30, 60, 90 triangle. It can be very helpful in 30, 60, 90s to label what you've got here. Hypotenuse is always easiest. The side opposite the 30 is shorter than the side opposite the 60. So this here is my 30. There's the side opposite. So that must be my shorter leg. So this is my shorter leg. This is my longer leg. When you're solving 30, 60, 90s, you always want that shorter leg. And fortunately, we have it. The way you get the longer leg is you take that shorter leg and you multiply it by the square root of 3. Again, don't get confused here. It's good that they're the same because the square root of 3 times the square root of 3 is just 3. So the longer leg, that's going to be 21. And then the hypotenuse is just the shorter leg, which is 7 square root 3, and times 2. And again, working with radicals, don't get confused. 7 square root 3 times 2 is just 14 square root 3. That's how many square root 3's I have. So we've got those. In our second set of examples, well, let's see, the first example here, we've got another 30, 60, 90 triangle. This time, we know the side opposite the 60, or the longer leg. So this is the longer leg. That would be the shorter leg, and of course, that's my hypotenuse. So I always want to get that shorter leg if I don't have it. So you go there first. The longer leg, I got that by taking the shorter leg and multiplying by the square root of 3. So to go back to the shorter leg, I'm going to divide by the square root of 3, which in this case is very easy. That's just going to be 5. And that's the length of my shorter leg. Once I've got my shorter leg, I can find my hypotenuse. Hypotenuse is just shorter leg times 2. So that's going to be 10. Shorter leg 5, hypotenuse 10. Let's see, this second example, they told me one of the acute angles is 60, which means this one has to be 30. I always write it in. There's just something about seeing that visual. So let's label our sides. Hypotenuse is always easiest. Side opposite the 30 is the shorter leg. Side opposite the 60 is the longer leg. So once again, like the previous example, I know my longer leg. So to get to the shorter leg, which is always where you want to go next, you're going to divide by the square root 3. And again, the example made it easy. So if you divide that by the square root of 3, you just get 3. Right, that's that guy. And then once you know the shorter leg, you double it to get the hypotenuse. So our hypotenuse is 6. Okay, finally, this one looks a little bit cryptic here. What's happening? I know if this piece is 2 and that piece is 2, I can add them together, and this will be 4. And now looking at my triangle, it's actually an equilateral triangle, which means all the angles in it are 60. So this angle is 60, and this angle is 60, and this entire angle is 60, but it is going to get cut in half here. So this one's 30, and that one's 30. And we've proven many times why if you have an equilateral triangle and you drop that out, you get two congruent triangles. And it makes sense anyway. One is 60, the other has to be 30. So I actually have two 30, 60, 90s. And if I just focus, say, on this part of it, I'll put that in a different color. I'm just going to look at this part of it. See, the side opposite the 30 is my shorter leg. And the hypotenuse is opposite the 90, and it's making sense. Shorter times 2 is hypotenuse. So side opposite 60, my longer leg, you take the shorter leg and you multiply by the square root of 3. So that h is 2 times the square root 3. And that's a very helpful thing. If you get a question like this, they might say, hey, find the area of that triangle. Where you're going to need that altitude. And for fun, let's just find that area. Area is 1/2 base times height. So in this example, the base is this 4, and this is my calculated height. So that's 4 times 2 square root 3. Half of 4 is 2. 2 times 2 rad 3 is just 4 rad 3, and square units. Anyway, I hope looking at these examples are helping you understand how to work with the special right triangles, and thank you for watching.